Okay, for Lab 6, we're going to be working in Synchro again, and this time instead of just looking at a single intersection, we're going to be looking at the entire division corridor. So, as you can see from my screen, it has all the intersections from south of the freeway, and then you can see some of the off-ramps onto the freeway, both headed in the southbound direction and the northbound direction. So we're going to look first just at some features that weren't that necessary when we had a single intersection, but are pretty helpful when you're looking at an entire corridor. And just to remind you that this is a portion of the Synchro file that the city of Spokane has, and they have a single Synchro file for the entire city. And so they look at a lot of their corridors and as different zones, and they see about the coordination of entire areas like downtown. What they originally sent me had both the division and the brown, so both the northbound and the southbound streets, but with the educational license that we're using, we're limited to 10 intersections. So we're just going to be focusing on the division, which is what our project is. So a couple of the icons up here at the top that are helpful when you have more than one intersection. The first one is this helicopter, which is just the select intersection icon, and it allows you to go quickly between intersections, and you can see all the division and sort of main. You can pick any one of these, and it both highlights it so that now the all the windows, the volume, the settings window for that particular intersection is highlighted, and it also sort of somewhat zooms into that. I did want to point out a little bit about some of these. You see this #1N. This is a way of Synchro sort of defining arterial progression. So the signals, it's sort of showing the signals on 2nd, 3rd, Main, Riverside, Spokane Falls, Sprague, Division, 3rd, any of the ones that have this pound or hashtag 1N are ones that the traffic signals are coordinated with. So we'll kind of talk a little bit more about that later, but that's one way that you can quickly get into looking at all the different windows that we did last time. Remember, you have to have an intersection highlighted before those become available. So some other things that we didn't spend too much time with, or we didn't spend any time on the last lab, are some of these toolbars here, and you'll notice that one is called Node, this one is called Lane Movement, and this is Link. These are just ways of displaying the results or the input from these intersections on one map. So I can highlight node numbers. This is on our node thing, and these are just the naming convention. It's giving each intersection a number, and then so these are an intersection nodes, and these other ones, these sort of blue or cyan colored ones, are just the end of the links. So a lot of the reports and things that you'll see will use these node numbers, so sometimes it's nice to see what those are. Probably more interesting would be to go ahead and just show the intersection level of service. So this is like I said, the current file. So it has all the sort of existing volumes and signal timing for division. And so by turning on the level of service, I can quickly see that the overall level of service is sort of B's for those. On the further north, we see C. And then the one that's not functioning well at all is this, where the off-ramp comes in by the, off-ramp merges with division, and at 3rd, where you have the Dick's Drive-In over here. So that's operating at level service F. And then we also have C. These U's are unsignalized intersections, so these are kind of junctions where they come in, where they're either stop or yield control. So they technically are intersections, but it's just where one lane branches off from the other. So they're just shown as sort of stop and free controlled. So instead of having a signal control type, it's just as unsignalized. We didn't really do much with that or anything with that last lab, so you can see that. So those are some of the, probably level of service is the most interesting one that you can show. You can also look at control delay. This is what level of service is based off of. And then there's also This one is just showing the cycle lengths. So we see those 90-second cycle lengths that we saw at Division and Sprague for the last lab. You can see that all of these are coordinated and they're at 90 seconds, and the only one that's different is the one on the other side of the freeway, south of the freeway, is fourth. It's running on a 78-second, which is kind of an unusual cycle length there. So I can also go to links, and I can choose to display the link speeds, right? So this is telling me what the speed limit is on each of those. There's some other things about the ability to be sort of coordinated lengths. This is just the length in feet between those. So, and then the distance is just showing some of the link distances between them. So it's quite frequently we'll show the level of service on the nodes, but not necessarily show link ones. The reason I'm pointing this out is that you're eventually sort of culmination of these labs is working on a short section for your design report that's talking about the corridor and how it's functioning, and so it might be nice to put in a graphic that just shows level of service, you know, for all the intersections existing, and then after you've made the changes at the end of this lab. So, and then the other toolbar up here is where you can see the different lane or movement settings. So this one just shows, you know, we have 3 through lanes. It shows how, you know, where the left turns are allowed. This is all coming from, you know, these settings at the intersection level where we set what movements and lanes were available. We could also do it by the volumes, where you can turn them on. It's not the cleanest feature when you have kind of strange intersection geometry, but it might be useful showing that. You can also look at level of service by movement as opposed to just the overall level of service. So each of these sort of through and left and right turns are going to have a level of service, so you can start to see, you know, for this intersection, which was failing as a whole, that both, you know, the through and the right movements on this off-ramp were at E and F, and then we had a level of service E from the left turns on third. So that kind of shows you what some of the particular movements are that are causing the entire intersection to fail. So if you've driven the division corridor, you've probably noticed that the signals are somewhat coordinated. So if you're not impeded too much by traffic and things are going well, you typically can get through all the lights, or at least you know, most of the lights sort of together on the green. And how that's done in Synchro is by setting what's called the offset. So if I look at division and third, and I go over to my timing settings, so we worked with this on the last lab, and we see it's pre-timed, it's 90 seconds, and it has all the various splits. But there's also a setting here called offset, and what it means is that this is the time in seconds from a reference point, which is the first intersection, sort of south of the interstate, and as we move further north, we'll see this offset number get larger, and so it's saying that relative to the previous signal, that the beginning of the green in the northbound direction, this northbound through at the beginning of the green, is going to come 10 seconds after the previous one. And so if I move to the next intersection and I look at the offset, I see that this is 15 seconds. So the intersection to the south would have been 10 seconds from a reference time, and then 5 seconds later at 15 seconds this one would have turned green, and so on. So as we move forward, we'll see that setting. So this is 26 seconds, and that's typically based off of the link distance and then the average speed, recognizing that there's, you know, some lost time certainly. So the idea is that as vehicles progress, that these sort of turn green in a wave as you get there. So one way to look at this is by looking at a time-space diagram. So what I did there is I just made sure I had a link along division clicked, and then up here is time-space diagram. So it's showing each of the intersections along division, and it's showing these bands here, showing the red, the green and the yellow intervals. So it has distance and then it has time along the y-axis. So these lines between them are what we call the green band. So, you know, can vehicles get through, right? So if they were going at a line that was, you know, 25 or 30, whatever we set the speed at, miles per hour, can they get through on that green part of it? And so this is just a way of sort of analyzing, you know, at this point, you see that 4th intersection, 4th Street, which is on the south side of the freeway, is not really linked to what's happening on the north side of the freeway, which kind of makes sense. But we start to see some fairly decent progression, right? So the way, you know, there's a certain amount that can happen of vehicles that can make it all the way through these green ones. And so the distance between one intersection and the other, where the beginning of that green starts, that's what's called the offset. So that's one way of visualizing that. Okay, so to run the sim traffic, just like we did in the previous lab, we just want to find that sim traffic animation. It's always going to ask if you want to save. There's a couple of things that happen on this one that I wanted to point out because it's going to look different, a little bit different with a coordinated corridor versus a single intersection. So we'll go through. This keeps coming up. The history file needs to recreate. Not a problem. It usually works fine. I had a couple times where it didn't want to generate that history file. So if that's the case, like in that one where it just sort of got hung up, go ahead and close some traffic and try it again and see if it will recreate that file. Yeah. So it worked that time. But I wanted to show, kind of flash really quickly, this sim traffic error and warnings. We're used to sort of seeing error warnings come up in software and thinking they're kind of fatal flaws. In this case, what Synchro is doing, it has different levels, error versus warning. And so it's checking certain things. And some of it is just, it's not considered good design. So this one is in reference to node 133, which is just saying that the link distance is too short for lane changes for the upstream channelized right. So it's just saying it's not good design to have that short a distance between an intersection and where a vehicle may want to be turning right or left. If you're familiar with the division corridor up in here, there's a lot of kind of strange weaving motions that come, you know, with these intersections. It also points out when it's not good design. So here it's less than 25 degrees. This is, you know, it's pretty unusual how we have a leg of the intersection essentially coming in parallel to the other. So these are just, they'll still run, and it's just sort of pointing out that, are you really sure that that's what your intersection looks like? And then some of these also have to do with some of the timing, dealing with some of the intervals, or what they call splits, which is the same kind of interchangeable with the term interval, is less than the minimum. So it's got a really short interval in there that they might not be considered appropriate and whatnot. So also the PED timing exceeds the maximum split. So saying that when a pedestrian button is pushed, it's going to be longer than the maximum of that interval. And then there's some other geometry things. Anyway, we don't want to spend too much time with this because this is a set of intersections that have been designed by the city. We're not going to change that, but it just does point out that there's a lot of kind of, I guess, quality control stuff within Synchro, saying, you know, you might want to not really design it that way, but if that's in fact how it is out in the field, then there's not really much you can do about it. I'm going to speed it up a little bit here. And if I remember right, it was kind of in here, we could see this a fair amount. So each of these intersections have volumes, right? So they've been set up and somebody's done turn counts. Well, there's also driveways and alleys and things. And so sometimes the intersections don't balance. And so you see this a lot here where vehicles come through and they disappear. And that's because we see a lot more volume coming into this intersection than we counted at this. And so the program doesn't really know what to do with it. And so in order to make sure that this approach has the right number of cars for that intersection, it kind of disappears. But you also see kind of later certain cars will sort of appear in that same part. And it's just because it really is done sort of intersection by intersection, but it needs to make sure that those volumes that are put in are matched. So you see those cars kind of appearing and disappearing. So it's something to check with. You see that a lot if you have like a big generator, like a big store or something. In this case, it's just the freeway, and for some reason the volumes on this link coming into it and going out of it are kind of strange. I actually think there's something, because they all sort of disappear but then they kind of come back up again. Just kind of something strange that I think has to do with the geometry. But that was the intersection that I saw it the most, but just kind of pointing out it's something to look for if you were trying to set up your own Synchro file. So anyway, you can see some of the issues. So this is the one that was performing the worst. So you can see some of the queues that form on the off-ramp, and then particularly on third will get pretty backed up as well. Okay, I'm going to close the sim traffic. We're mostly using the sim traffic to make sure that things are operating the way that we expected to. So the last thing I want to show, mostly what you're doing in this lab is you're going to be reporting on the existing conditions, so using sort of current traffic volumes, how is the corridor functioning as a whole as opposed to a single intersection. And then you're going to be using a second file where I've gone through and adjusted all the volumes so that they represent the future traffic volumes. So I've taken the information from the travel forecasting model that we used, I think in like the second week of class or whatever, and kind of updated that where we have less volume on division because of the future North Spokane corridor going in. But then we also see some of the cross traffic increasing because of just general increased demand downtown. So with those two things kind of together, we get new volumes. And if you look at the division corridor, it has 3 lanes. And in some cases it has additional lanes, but in general there's at least a minimum of 3 lanes that are moving all the way through. One of the questions that's come up is that they'd like to put in a new transit corridor downtown. So similar to what's being proposed for the Central City line, which is going to come through Gonzaga campus and then go down Spokane Falls Boulevard, where it's a more high capacity transit. In the future, they'd like to do that on division and actually take one of the lanes away. So instead of having 3 through lanes for traffic, it would be 2 lanes for traffic and 1 lane for the bus. So with this lab, what you're going to be doing is updating this so that not this particular file, but updating the file that has the future volumes and seeing if you can reduce the number of through lanes to 2 so that this one would only be for buses. So and if that works, or see what the operational issues are with that. So a couple of things back in here. So if I wanted to just create the reports for the entire corridor, it's over under File and Create Reports. A couple of things. If I try to run the HCM 2010 reports, I'm just going to hit that and do preview so you can see what will happen. In some cases it will work, but there's a lot of what they call non-traditional signal phasing that the city is using. So most of the reports end up coming up as non-standard, what they call NEMA phasing. So what kind of looking into this with the city, everything, they seem to be analyzing everything using the previous methodology, which was HCM 2000 signalized. So if I do that, I actually will see that every intersection I get a report for. I don't get any more errors. So I just wanted to point that out, that File, Create Reports, and so you'll be using the HCM 2000. The other thing is that previously we were just using single intersections, and it was defaulting to what we had clicked. I can change which report I do by selecting single intersections, but for this we're just going to do the entire network, so it's going to provide a single report for each of the intersections without having to generate those one by one. So pointing that out. So if I was updating this and trying to reduce the number of lanes on division to 2, first you're going to be using the division instead of the division.syn. You're going to use the division underscore 2040, so it's a 2040 one, but I'll just show you in this one. And then you would go through, and instead of your northbound looking like this, you would want to reduce it from 3 lanes down to 2. So instead of having 2 throughs and that, we would change it to a through and then a through right. And anytime we change that, we want to go through and go back to the signal, and this will be in the directions too. Be sure not to optimize the cycle length because we want to fix that at 90, but you would optimize the splits, and so it would change what was happening there. But you're going to do that with the new volumes in that 2040 file. And then run, so you'll have a set of reports for what it looks like in existing, so 2017, and then you'll have a set of reports for 2040, and then that's what's going to be incorporated into the design that we do all the last part of the semester. So